This is question number 2 taken from exercise 9.3. What does it says? It says a chord of a circle is equal to the radius of the circle. So what we can do, first we are going to make a circle, and let's say I made a circle here. So let's say this is a circle. Further it says there is a chord, like I can join any 2 points on this circle to a chord to make a chord, but it says the chord has to be equal to the radius. So I can say this being the center, and let's say join this and this as well. Right. So this is O center. AB is the length of the chord, and it's given this chord AB is equal to this radii. So clearly it is an equilateral triangle. As we read the question further, it says that find the angle subtended by this chord at a point on the minor arc. So clearly this is the minor arc, right? And this being the major arc. So we have to find the angle subtended by these two, subtended by this chord at a point on the minor arc. So I can take a point, say I took a point P here and join with A and B so as to find the angle subtended by the chord AB, by the chord AB at the minor arc, that is angle APB. And I took another point, I can take anywhere, say I choose a point somewhere, say here. I can take here also, not a problem. Anywhere on the major arc, right? And let's join this also, right? We have to determine this angle, say angle ARB. So in short, we have to find this angle and this angle. Now, first of all, we are going to apply the property of an equilateral triangle. As you can see that this is an equilateral triangle, and in an equilateral triangle, all sides are equal. That's why it's an equilateral triangle. And we also know that each angle of an equilateral triangle is 60 degrees. So I can say this angle is 60 degrees. This angle is 60 degrees. Now check, this angle is subtended by this arc, called the minor arc, at this center, right? And this is how much? 60 degrees. Now we have a property, what's this? That the angle subtended by an arc at the center is twice the angle subtended by it on the remaining part of the circle. So clearly we can say that this angle, that is, we can say this angle will be twice of this angle from the property, right? So we can say this angle is twice this angle. So I can write that as a angle R, or I can write the angle at the center, which is angle AOB, will be twice the angle ARB. Now replacing AOB with this value, that is 60 degrees, is equal to twice angle ARB. So clearly angle ARB will be, angle ARB will be half of 60, that is 30 degrees. Now once we get the value of this angle, which is 30, now we can say that we can use another property called opposite angles of cyclic quadrilateral is supplementary. As you can see from the figure, that this figure A, R, B, P, and A. That means this is forming a cyclic quadrilateral. You should know that a quadrilateral whose all four vertices are on the circle, as you can see, A, P, B, and R, these all points are on the circle, and we know that a quadrilateral whose all points are on this circle, right, is called a cyclic quadrilateral, and we know that opposite angles of cyclic quadrilateral are supplementary. As you can see here, this plus this will be 180, and this plus this will also be 180. So we are going to use this property to find out this value. As I can see, AR and AR opposite angles of this quadrilateral. So angle R plus angle P is equal to 180 degree. So angle R, which is 30 degree, plus angle P is what we have to get is 180. So clearly angle P will be 180 minus 30. So angle P is equal to 150 degree. This is the two angles we have to determine. As you can see in the question, one, we have to find the angle subtended by this chord, in the minor arc, and the minor arc is angle APB. And also on the major arc is this angle, that is, this is ARB. We calculated both of them.